System maintenance. In this nugget, we're going to talk about creating RPM packages and backups. We already know quite a bit about the RPM command. One aspect of that command that we haven't talked about yet, though, will create an RPM package from source code. To do this, you need to create what's called a spec file, which we'll talk about in some detail. And then we'll move on and talk about backups, and we'll build upon what we talked about in the introductory series with regards to backups. Well, pull up a chair and let's get to it. We're going to start out this nugget by talking about how to create RPM packages. Now, we already know about the RPM command and the RPM utility, right? We know how to install software using the RPM utility. We know how to remove software, how to update software using the RPM utility. We talked about all that back in the intro series. We also talked about how to build software from scratch or from source code. So given some source code like a C program or a C++ program or something like that, we learned how to take the necessary steps to turn that into an executable piece of code. All right, now what we're going to do is combine these two ideas. We're going to take the knowledge that we have about RPM packages, we're going to take the knowledge that we have about building software from source, and we're going to combine that knowledge and take it a step further so that we can take some source code and create an RPM package. And that lets us distribute the source code or executable versions of the source code to a wide audience of people that use the RPM utility. All right, so what do we have to do to build an RPM package? Well, the first thing that we have to be able to do is we have to be able to compile and install the source code locally. So maybe we've actually written the source code and we've compiled it, installed it locally. Maybe the source code came from somewhere else, and we're taking that source code on our local machine and we're trying to get it running on our local machine. If that's the case, we might actually have to make a patch of changes that are necessary to make that source code run on our local machine. But maybe we only have to do the first step here, maybe we have to do the first two steps depending on where we got the source code from and that sort of thing. Okay, so once we've got the source code, so it's all set up to compile and install and it runs perfectly on our local machine, then what we're going to do is we're going to make this .spec file. Now the .spec file is what tells the RPM utility how to build the package. When we go to build the RPM package, the final step here is to actually build the package, we're going to use the RPM command. Just like we use the RPM command to install an RPM package or upgrade an RPM package and so on, we're going to use the RPM command to build the package. We're just going to use an option to the RPM command that we haven't even used yet, okay? And that RPM command with the -build option will look at the .spec file that we created, and the .spec file will contain all the necessary information for the package to be built. Okay, so really what we're going to concentrate on here is the .spec file. How do you create this .spec file, and what is it? Well, the .spec file first describes the software. It's going to have some comments in it, like this is software to do this really cool thing, and masquerade DNS addresses or whatever. Okay, it's also going to have details on how to compile it. So the options for making the system and things like that. Then it also has to list all the binaries that get installed as a result of installing the RPM package. This is a really important feature of the .spec file. So the .spec file has many sections to it, and the first section is the header, and the header has the summary of the software, the name of the software, the version like 2.0.1 or whatever, copyright information, whether it's under the GNU public license or whether it's some commercial license or something like that. The next section of the spec file is the prep section, and that's steps to prepare the source code for installation. So if we need to apply any patches or anything like that, that all happens in the prep section. Then there's a build section, so these are the commands that you would use to compile the source code. They're placed in here. Now, before we go on to look at more sections of the spec file, each of these sections is really they're denoted by %sign prep will denote the beginning of the prep section. But in the prep section, really what's going on is it's really just like a shell script. So you could put commands directly in there. There's also some macros provided that you can use to do some common tasks that you would do in the prep section and the build section. But the same goes for all these sections that we're talking about. They're really, you can just put, shell commands in there like make install or make or something like that can be included right in the build section. Okay, some other important sections of the .spec file is the install section. So what this is going to do is it's going to install the software relative to a build route. Now back in the header, one of the things that gets specified in the header is the build route. So when you're doing this on your sort of development machine, your build route could be like /temp/ Perry's application or something. And I could be building it all in there. But when you're going to distribute it out to the rest of the world, maybe the build route should be like /opt or something, or /user source, or whatever it's going to be. Okay, then there's a clean section. This has commands in it to clean the build route. So when you're doing multiple installations or multiple compilations of the source code to get it to install, your build route is going to be all dirty with all sorts of object files and all kinds of junk in there that you don't want. And so the clean section will go through and clean all that stuff out so you're starting from a fresh slate. And then the files section, this was what I was saying before, is a very important section of the spec file. And this must list all of the files for a binary package. There's lots of discussion out on the internet about how to do this efficiently. When you have really large RPM packages, there's lots and lots of files that are part of that package, and how do you list them efficiently? Some people have written some scripts and distributed them out to people, and then other people said these scripts don't work because I have a multi-user system and it included other files that were part of the package that I didn't want distributed, and so there's lots of discussion on how to do this efficiently. I mean, if you have a small package, you can just list the files out by hand, but if you're talking about a very large RPM package, the number of files could be in the hundreds, and you've got to list them all here, and how do you do that without typing them all out by hand is an issue that we're not going to talk about, but you can look up that sort of information on the internet. All right, well now I just wanted to point you to a resource that you can find on the internet about creating RPM files. If you do a search for creating custom RPMs, there's a two-part series in here written by Roderick Smith. So you can search some aspect of that and you'll find this column out on the internet. And part two is nice. Part one basically talks about what we've just talked about on the whiteboard. Part two actually has some examples that you can follow, and if I scroll down here, here is the second example here. Just shows you a .spec file, and we can just walk through and see how some of the things are set up. So the first part here is the header, like we were talking about. He's specifying what the piece of software does, its name, its version, its release, the copyright environment. The group setting is mostly used in Red Hat systems for classifying what package group this belongs to. So when you pull up some sort of graphical user interface and you want to mess with the packages, well, like the first level will be called system environment, and the next level will be called daemons for this particular package. And then there's the full name. This source should actually all be on one line, but it's just been formatted funny. So they give the web address and the tar.gz file of the source code. And then there's the build route. Now this is important because this is where the process is going to be built, and you can see it's set up to be in var temp, and then % with the curly braces and the name in the middle, that resolves to this name. So that so the actual directory where the build will be done is var temp DNS mask hyphen build route. Okay, and that's going to be the place where the process is built. All right, and there's also a requires thing in here, so that if it requires another package, you can specify that. As you go down, there's the description, just a few sentences. Here's the prep section, and they're using a macro called setup. In there, you can learn about all the various macros that are available in here. If you pull up the RPM how-to page, it'll go through all of the different macros that are available to you. In the build section, he simply does a make. In the install section, he does a cleanup. Notice he does a remove minus RF, which is going to remove everything on the system recursively, but starting in the RPM build root directory. So you want to make sure that this RPM build root is not set to slash or something like that. Then he goes ahead and makes some directories. And you can see this is just like a shell script. He's just typing commands here like you would type at the command line. Does a couple copy statements and sets everything up there. Again, the clean section goes through and removes all the files from the build root so that that's clean and there's no conflicts with other files from past builds. The post section we didn't talk about. This is just something to do after the build and the build process has happened. There can also be a pre-section if you want to do a few things before you go ahead and build. As we go down farther, then you can see the files section here. Now, the files section, like I said, has to list all of the different files that are part of the binary distribution. Okay, and this is the way he does it. He's using some macros here to list out all of those different files. And like I said, there's lots of different ways to list out the files. At the very worst, you'd have to list them all by hand. But if you use some of these macros, you can cut out some of that work. Okay, then there's also a change log at the bottom, and this should be specifying what changes you've made to the source code for this particular release version. So for instance, if you are the maintainer of some piece of software that people use and you distribute as RPM packages, then that change log should be a very detailed specification. You could say, I fixed the bug related to drawing the screen when this particular resolution was set, or something like that. And then you can specify that so then people can make informed decisions about whether they need to upgrade the RPM or whether this particular RPM is going to fix this problem that they've had and so on. Well, now let's shift gears and talk about backups. Now, in the intro series, we talked quite a bit about backups. We talked about full backups versus incremental backups. We talked about backup strategies that you could use. We also looked at linux-backup.net, which is a great resource for learning all about backups. You can learn about different kinds of backups. You can get all sorts of example scripts off that website. You can learn about how to schedule backups, how to restore backups. They talk about everything from low-end solutions for home users to high-end solutions for enterprise systems. Okay, so all of that was, we covered all of that. Now what I want to do is actually take another step forward here and look at a particular backup script that I've pulled off the internet. And let's just take a look at this and sort of talk about some of the things that get done in here and why they get done, what kinds of foresight they're having by taking some of the steps in here. So this is just a bash shell script. We've talked about bash shell scripting in the past, and we'll talk more about shell scripting in the next nugget, and we'll talk about Perl scripts as well. But you should have the ability to be able to read the shell script from what you have now. I'll fill in some details if I think something's a little bit more advanced than what you know maybe already. Okay, so a few variables are set up at the top. Backup_log and backup_error are set to two particular files on the system, in this case in the user local directory. Okay, you can obviously modify these to be wherever you want on your system. The first thing that gets done is they move a copy of the current backup log to backuplog.old, and they move the current copy of backup error to backuperror.old. So the old log and old error files are now backed up to their original names with a .old appended to the end, and that gives us sort of a fresh slate for the current backup. So the current backup will print out messages to backups log and backups.error, and that will be all fresh information from this backup that we're executing with this script. Okay, so a few print statements are done, right? The echo is just a print statement. So a few print statements are done. The backtick date there prints out the current date and time, and then all of that goes into either the log file or the error file, depending on which echo line we're talking about. And then the next thing that happens is we cd into /mount/data. So this is just where you would, this is the mount directory, the particular directory that we're going to back up. Again, customize that for your particular installation so that you're backing up the correct data for your particular installation. Then the tar command is used to do the actual backup. So the C command, or the C option, says to create a tar archive, create a tape archive, use the verbose mode, and then we're going to specify a file or a device. And in this particular case, they're specifying ST0 as the device, the first SCSI tape drive. Now, if you don't have a SCSI tape drive, obviously you specify another device that you're going to back up and store this tar file to, right? Just because tar stands for tape archive, right? We don't have to actually write this to a tape. We can write it to a hard disk or somewhere else, and then, you know, put it on a CD or a DVD or whatever we want. Okay, so they're actually using the SCSI tape drive here, and they're backing up the current working directory. That's what the dot stands for, which is now mount data, because we just changed directory into mount data. And then we use the 2 followed by 2 greater than signs. In shell scripting, the 2 stands for standard error. So anything that gets printed out to the standard error facility will get printed to the backup error file. Okay, and backup error, remember, has been set up here to backups.error in the user local directory. Okay, so so the double greater than sign there does, it appends the information that gets printed from standard error and prints that to backup error. So whatever was in the file already is still there, and the append operator just adds it to the end. Okay, so it doesn't overwrite what was already there. And you can see we use the append operator up above as well. So anything that was already in the backup error file, this information just gets appended to that particular file. All right, so this is what actually does the backup. This is the command that actually does the backup, and tar is a perfectly good utility to do backups with. Okay, and in this particular case, we just did it to ST0. Now the next couple steps are an interesting step in this particular script, and this is why I picked this script. And it's because what the next thing they do is they use the MT command. MT stands for magnetic tape, and they specify the device, dev ST0, the exact same device that we just wrote to, and they say rewind. So immediately after they're done writing the tape archive out to the first SCSI disk, they rewind the tape, and then they print out a message saying we're verifying the backup, again printing out the date, and that goes into the backup log. Okay? The next thing they do is they use the tar command again with the -T option. Now this time, the T option, what it does is it prints out all the files that are in that particular tape archive. If any errors pop up to the system again, anything gets printed to standard error, that gets printed out to backup error, and then again another message gets printed out saying backup complete at this particular date and time, and that goes into the backup log. Then what we do is, the next thing they do is they actually append the backup error log to the backup log. So anything that was printed to backup error now gets appended, the double greater than sign, to the backup log. And the very last thing that happens is they mail with the subject line of this, that's what the -S stands for, use this subject, so backup status report for mount data. They mail that to the root user, and the thing that they mail to the root user is the backup log file itself. So this operator is a less than sign that says give that as input to the mail command. So that backup log file gets mailed to the root user. Well, now that we understand what this script does, let's talk a little bit about why it does what it does, and also let's talk about some common pitfalls that people run into with backup routines, and talk about how to avoid them. Okay, so one of the things that this script does that I really like is this whole verification process. All right, you don't need to be writing to a tape drive to do this verification process. You can also just print out a copy of what gets backed up during the initial tar utility here. So while tar is operating, it will print out all of the files that it's saving to the archive. Okay, and later if you do a tar -T command, that will print out all of the files that are in the archive, you know, after the fact, after you're all done writing to it. Okay, so you could actually save the output of this file to some particular file like a tar backup log, and then you could write the output of tar minus t to like a tar verify log, and then you could do a diff on those two logs. Okay, so the diff command will go through and verify to see if there's any differences between two files. So if during the creation process a particular file was listed, and then during the verify process that file was not listed, well then during the diff that you would do after this, you would see that there's some discrepancy there. Okay, and then you can take measures to fix that before it becomes catastrophic and the disk fails. Okay, and you actually need that backup tape or that backup archive to restore some data to your system. So I read a story once in an old Linux magazine, and it said, you know, they had this whole backup routine in place at this one installation, and something crashed one day, and they had to start restoring stuff. So they went back to the full backup that was 1 day old. They did full backups every night, and they went back to the full backup that was 1 day old, and the tape was blank. They went back 2 days, the tape was blank. 3 days, the tape was blank. The tape was blank for all of the backups they had done, and it's because they hadn't formatted the tapes before they tried to write data, and so there were errors in the process, but they just didn't get caught because they never verified that the data was actually written to the tapes. So this verification step, I think, is just so critical for backups because, I mean, the backup is no good unless you know what's on that particular backup tape. And even if you know that just like one file is missing, at least then you know that there's a particular file missing and something happened during the process, and so you can just go and rectify that. If you saw that the entire thing was missing during the verify step, if you saw that there was just tons of differences between the output of the initial tar, then again, you can fix that the very next day when you get this mail message and you see all the errors that popped up from the verification step. Okay, another mistake that people make commonly with backing up systems is they back up to the same disk. If they don't have a tape drive or they don't write it out to a CD, they don't have a zip drive, oftentimes people will just create a tar archive and then put it on the exact same hard drive where they're backing up data from. And maybe they use a separate partition and that makes them feel better about things. But typically when disks fail, it's a pain to get information out of one partition to then restore to the other one. So, you know, a better solution is to back up to a completely separate device, whether that's a SCSI tape device or whether you're going to create this tar archive and then burn it to a CD or a DVD, depending on how large it is. A solution that I think is really simple and pretty economical nowadays is to just back it up to a separate hard drive. You know, I got a hard drive recently, I think for $9 because I got like, you know, $70 worth of rebates back on this $79 nice Western Digital hard drive. And so you could just add another hard drive to your system and leave it offline all the time. And then when you go to do the backup routine, you can mount that hard drive, then you can create the tar archive, you can write out that tar archive to the disk drive that has been designated as the backup disk drive, and then that backup disk drive will have exactly what you want on it, and it'll be really easy and fast to restore that data from that disk drive if your primary disk drive ever failed. It's kind of like what we were talking about in the last nugget with RAID, and RAID level 1 had this mirroring capability. Well, you know, that's a little bit of overkill because every time you do a disk write, you also have to write to the mirrored hard drive. But the idea is good in that, you know, hard drives are reasonably cheap, and using one as a backup device is not that far-fetched. So one last pitfall I wanted to talk about with regards to backups is that you really want to automate everything as much as you possibly can. We talked about the cron facility in the introductory series, and that allows you to run a script or a particular job at the exact same time every day or every week or certain jobs every day and other jobs every week and so on. And it's not the important part of that is not that the script actually runs at like 2:15 a.m. at every single day. It wouldn't matter if it ran at 2:15 one day and 2:30 at some other day and 2:10 at some other day. What's important is that the script runs in the exact same environment every single day. See, if you rely on humans to type in commands, well, obviously the humans could type in a command wrong. All right. If you gave the human a script, then they can run the script, but perhaps there's some other variable there. Like, 4 days out of the week, Joe does the backups, and his account has permissions to read all of those directories that you need to read to do a backup. But then on that one day a week, when Joe's off and Mary does the backups, maybe her account wasn't set up correctly from the beginning, and so there's some sort of error messages that come up when she's doing the backup. And so her backups are bad because her account doesn't have the right permissions. Okay, so you can get around those variables by, if you do want it to be manually done every night, or you have so many different systems that you want to back up, you want some more manual control and things, well, you could set up a particular account, not the root account, but you could create a backup operator account that has just the right permissions, and then everybody who does a backup, no matter who they are, would log into that particular account so that they would have all of the correct permissions and the correct scripts would be there and everything like that. But like I said, the more that you automate it and test the automation, the better it is, because you know how us humans are, right? That we do things differently every time, and we mess things up when we have the opportunity to, and we always seem to mess things up at the worst time, right? So you always want to automate these things and test out the automation routines as much as you can, especially if you're in some sort of an enterprise system. Well, it's time to wrap up our nugget on system maintenance, and we covered two major categories in this nugget. First, we talked about creating RPM packages. So if you get a bundle of source code, you can create an RPM package for that source code with the RPM command. But one of the most important things to accomplish that is you have to create what's called a spec file. So we looked at what you can do in a spec file, what kinds of things you have to specify, and also we looked at an example spec file. Now, that resource that I pointed you to on the internet is a really nice resource. It walks you through the step-by-step process on how to create an RPM package. Don't forget about the RPM how-to page as well. They have a section in that how-to page on creating RPM packages, and they go through all the macros that are available to you to use in the spec file to make your life easy. And then we moved on and talked about backups and build on what we talked about in the introductory series. We looked at a very simple yet elegant backup script, and we talked about what they did in that script and why they made those choices. I also talked about some pitfalls that you could run into with the backup procedure, and I just can't stress how important it is to have a good backup procedure in place and make sure that you test it out and verify that everything works, because when you need a backup, that's not the time to discover that there was a bug in your backup script. All right, well, I hope you found this nugget informative, and thanks for viewing.